Okay, so let's start today class. So what we are going to discuss? We are going to discuss electromagnetic spectrum. Okay, electromagnetic spectrum. Electromagnetic spectrum. What is electromagnetic spectrum is? Electromagnetic spectrum is all the different electromagnetic waves, right, combined together is called electromagnetic spectrum. So electromagnetic wave is not a particular wavelength, okay, it has a range of wavelength, a wide range of wavelength it is. So we have different orders of wavelength, like for example smaller wavelength, then larger wavelength, then very high wavelength, like that. So it's like a combination of so many waves, right? All the waves, or you can say group of waves, right? So electromagnetic spectrum means what? It is a it is a it is a range of many different different electromagnetic waves, electromagnetic waves having different different wavelengths or frequencies. Okay, so what are those different wavelengths, okay, that we can also note? Electromagnetic waves has widely varying frequencies. So let's note that. So frequencies are range of frequencies. Let us write frequencies frequencies ranging from what are the range of frequency? Write it 4.3 into 10 power 14 hertz to 7.7 into 10 to the power 14 hertz. Okay, that's the very no wide varieties of this, and some of these wavelengths, okay, can produce. See, I think these frequencies, but we can have different ranges of means different frequency will be there, which we will call a different name, that we will see. But this is the range of frequencies, okay. Those having frequency in the range of this to this produce sensation of vision. So see, this frequency, let us categorize it. This is one category, frequency ranging from here to here produces. So this is one range of frequency. There is another range of frequency will come, then another range of frequencies will come. This is one range of frequency, okay. So this produce sensation of vision, sensation of vision, sensation of vision. So we are able to see light, right? So I think this category is called visible light. Sensation of vision means this category is called visible light, visible light. Then there are other things like infrared radiation, gamma radiation, gamma rays. Then there will be ultraviolet radiation. So many things will be there, but visible light frequency is this range. Okay, visible light is a part of electromagnetic spectrum. Okay. Then what else? Then others are there. Others we will write it, but let us note that there are other things also, including ultraviolet, UV rays. Then there are infrared rays, infrared rays. Infrared itself can be categorized into three. One is far infrared, far infrared. Then there is mid infrared, mid infrared. Then there is near infrared, near infrared. They have the frequencies. Those frequencies you will learn afterward, but right now only I have given the range of frequency for visible light. Okay, there are others also. Let us note other things also. uh, ultraviolet, infrared, microwaves are also there. Microwaves, microwave radiations. Radio waves are also there. Radio waves, radio waves. Then this gamma rays are also there. Gamma rays. So right now I have just written which are not in order. Order wise I will also arrange it. Okay. So first note down all these different radiations. All these are electromagnetic waves, right? And they have different range of frequencies or wavelength. Everything is called electromagnetic spectrum. Okay. Right. So now I think let us write one by one. But I will give some order. Order we should remember. Some order of frequencies or order of wavelength we should remember. So let us consider the this way is the increasing order of frequency. Okay, frequency, increasing frequency. If I say increasing frequency, this order. So first will come gamma rays. Okay, gamma rays is highest frequency. Gamma rays highest frequency. Then gamma rays. After gamma rays is what? X rays. X rays afterwards. Next, X-rays are also there. I think I missed here to write X-rays also. If you want, you can write it. X-rays are also part of this. So X-rays will come second frequency, lower frequency. Then after X-rays, ultraviolet rays, UV rays, UV rays. UV rays means ultraviolet. Then next will come visible light, and next will come infrared, infrared rays. After infrared rays, we'll have, I think, microwaves. Yes, microwaves. Microwaves. After microwaves, we have radio waves. Radio waves also can be different type, amplitude modulated, frequency modulated. All these things are there, but right now, let's not focus into that. So this range, this you have to remember. This order you have to remember. So gamma rays have highest frequency, then X-rays, then UV rays, then visible light, infrared, microwaves, radio. In visible light also, there are different colors, right? Starting from violet, indigo, blue, green, yellow, orange, red. Okay, so above violet is ultraviolet and below red is infrared. Okay, so this is also in the order of increasing frequency. Okay, this is also increasing frequency, increasing frequency. Okay, so this is the order of increasing frequency. So radio wave has minimum frequency and gamma rays has highest frequencies. Okay, this is whole electromagnetic spectrum. Now, what type of questions comes in NEET or even in JEE Main or any other competitive exam or including your board exam? They may ask you to write the increasing order or decreasing order of frequency, all the electromagnetic waves. You can write, and also note that this is the increasing order of frequency and this is the increasing order of wavelength. Wavelength and frequency are inversely proportional. So this is increasing wavelength, increasing wavelength. Here also, this one. This is increasing wavelength. So wavelength wise, if you take wavelength, highest wavelength is radio waves. Radio wave has highest wavelength. Okay, and gamma rays has smallest wavelength. Okay, and also note that this formula right now you just note it. Afterwards, I will explain that energy is equal to h into frequency. Okay, energy is equal to this. You will study in photon theory. H is called Planck's constant. It is called Planck's constant, Planck's constant, and F is called frequency of electromagnetic wave. E is the energy of photon. Energy of photon. So it is believed that scientists believe that the electromagnetic radiations, whether it is any kind of radiation, it doesn't matter. Each electromagnetic radiation is made up of small particles, not particles, small packets of energy, that is called photons. Okay. So photon theory was basically given by Einstein, for which he got the Nobel Prize. Okay. So photon theory of light you will be studying in the next chapter, means dual nature. When you start dual nature after ray optics, wave optics, then dual nature will be there. There you will be studying that. Okay. So photon is nothing but packet of energy. So electromagnetic radiations are made up of small packets of energy, and the energy of the photon of a particular electromagnetic wave is given as h into f. H is Planck's constant, it is a constant. Okay, and f is the frequency of that. Okay, so you can clearly see that energy is proportional to frequency. So that means highest frequency will have highest energy. So in terms of energy also, you can say that this is increasing energy, increasing photon energy. Photon energy order is like this. That means gamma rays has highest energy. Gamma rays photon will have highest energy. Radio wave photon will have minimum energy. Right? Here also this is same way, energy increasing order of increasing or increasing this energy frequency, increasing energy, increasing photon energy. So if you take violet color or blue color and compare with red color, this violet color will have highest energy, red color will have lowest energy. Okay, like that. Okay, how much energy, another thing that you can calculate if you know the frequency. Suppose if you want to calculate the frequency of the violet, so I think I have written here, if you see here, this frequencies values I have already written here. This frequency 4 into 10 power 14, and this is 7.7 into 10 power 14. This is for visible light. So this is for violet and this is for red. If you want to calculate energy of that photon, so you can put in this equation H into frequency. Planck constant value you can substitute. Planck constant value is 6.64 into 10 power minus 34. That value right now you don't have to worry, but if you want to write, you can write it. Planck's constant value H. This Planck's constant H is 6.64 into 10 to the power minus 34 joule second. Okay, this is Planck's constant. So if you substitute the frequency of visible, let us say violet color, if you substitute frequency and H is this, you can calculate the energy of that photon in joules. That you can calculate. Okay, that we will see calculation afterwards. But right now you need to remember this order. This is the increasing order of frequency or increasing order of energy. This is the increasing order of wavelength as you go down. Clear? All of you have got this idea. Yes? All of you have understood this. Okay. Then let us write down the applications of that. Some of the applications I will write, and then NCERT, I will refer to NCERT to write the values of wavelength. Okay. First, let us see the applications of this. Applications of electromagnetic. Applications of electromagnetic waves. Okay. So let us start with the lowest energy. If you want, let us start from the, or let us start from highest energy. You go from highest energy. So gamma rays. Let us write for gamma rays. Gamma rays. Gamma rays. If some values are there, I will write. So gamma is wavelength. I am referring to a different notebook. Lastly, I will refer to NCERT also. So first, let me write. This is from SBT. Let me write this wavelength. So wavelength lambda is ranging from 10 to the power minus 14 meter to 10 to the power minus 10 meter. Okay. So wavelength of gamma rays lies between this. This is the wavelength range. Okay. What are the applications? Let us write applications. Applications. One of the applications is uh, they are commonly used to destroy cancer cells. To destroy cancer cell. To destroy cancer cells. Okay. Then anything else? Um, this interaction of electromagnetic wave with matter takes place by electric and magnetic field. These fields set in oscillation. Real interaction depends on the phenomenon of scattering and observation of wave. Infrared rays having a wavelength higher than the are capable of inducing vibration terms in molecules of the substance. This vibration frequency enhanced temperature. So the question is, now you can ask question like how it destroys cancer cells. How it destroys cancer cells. So when the electromagnetic radiation, this gamma rays, when it falls on the material, so that photon of that radiation will interact with the materials or cancer cells. So when it interacts, it transfers energy, and because of that, temperature of the um, that cancer cell increases, and that because of high temperature, it gets destroyed. Right now, we don't have to go into more detail of that, but only thing that you need to understand that these photons of the gamma rays, when it interact with the cancer cell, it increases its temperature, and due to high temperature, the cancer cell gets destroyed. Okay, that much you can understand. How it interacts and all these things are still not understood. People are still, studying that, because there may be some quantum effects also. Quantum physics can also come there, because it's a very very small, electromagnetic radiations, and their behaviors are different. It's a particle behavior as well as wave behavior. So that we don't have to go into that. Okay, so it is used to destroy that. Then then question can be, so this is one of the application given in this book. Also note that how this is produced. You may ask like how gamma rays are produced. So that point also note. There they have high frequencies, and this high frequency radiation is producing nuclear reaction and radioactivity. Note that. So gamma rays, gamma rays are produced in nuclear reactions, and radioactivity. Radioactivity. Okay. So radioactivity is also a nuclear reaction only. It's type of nuclear reactions. So radioactivity or other nuclear reactions, these gamma rays are produced. In nuclear reaction chapter in modern physics, you will see how nuclear reactions produces gamma rays. That you will see afterwards. Okay. So right now you should note that gamma rays are produced by which method and what is the application. This is one of the application. Let us move to next. Next we are going into X-rays. X-rays. X-rays are also high frequency. Okay. X-rays are produced when, how it is produced? Let us write this, how it is produced. So X-rays are produced. X-rays are produced when high speed electrons, when high speed electrons, when high speed electrons are or bombard, high speed electrons bombard a metal target, a metal target, particularly nickel crystals. No, so very high speed electrons are going to hit some nickel crystal or some metal target, and in that process these X-rays are produced. X-rays are there also in your syllabus. Okay, Might be it is removed or not, we don't know, but I will check that. But X-rays was there. X-rays we used to cover that in the class. In atomic structure, we used to cover that. Okay, that we will see. So X-rays are produced using this method. Okay, that is the method how it is produced. And what is the wavelength range? Note down the wavelength range, lambda. Lambda wavelength is 10 to the 10 nanometer, 10 to the power minus 4 nanometer, 10 to the power minus 4 nanometer to 10 nanometer, 10 nanometer. This is the wavelength of that. Okay. Also note that X-rays have very high, X-rays, X-rays have very high, very high penetration power, penetration power. Okay. So X-rays can penetrate into even hard substances. So X-ray has got medical applications. Any bone fracture and other things, they can see the X-ray scan. So how do they think? The X-rays have high penetration power, means it can penetrate through the muscle, but it cannot penetrate through the bones. Bones are very hard. It cannot penetrate through the bones. So we can scan the bones and take the picture, and we can figure out through what X-rays has passed and through what X-rays has not passed. So X-rays has passed through the muscles, but X-rays have not passed through the bones. So like that we can distinguish the diagram and we can figure out where is the bone structure, what type of structure of bones are there, or if there is any fracture or cracks in the bone. Those things can be found out from here. Okay. They are used in detecting bones. Applications, right? Applications. Applications. X-rays are used to detect fractures, fractures in bone. Okay, that is one application. They are also used extensively in security checks at airports and other places. Okay, note that this X-rays, other applications also, right? X-rays are used. X-rays are used extensively, extensively at airport, at airports and other places, and other places, and other places for security checks, for security checks. So suppose if a person is carrying some hard object like a gun or some weapon he is carrying, and if you pass X-rays, that's why in the airport the people are scanned, right? So that they should not carry any hard metal objects, huh? And we can scan it, and in the images we can see, right? That they can figure out. Hmm. But here it is said also that excessive use is. I will give one more application, very important application, which is not there in this book. I will give that. Okay, that is, note that it is called X-ray diffraction. X-ray diffraction. X-ray diffraction is a very important technique. X-ray diffraction. X-ray diffraction. X-ray diffraction is used in industries, in industries and research labs, research laboratories to study the crystal structure, crystal structure of materials. X-ray diffraction is a very important technique which is used in industries. In most of the places they are using it. Okay, and this is used in laboratories, also in research institutes like in IIT Madras. We had that facilities, and many students used to go to study the material structure. Okay, once I also went to do that. It's a facility in different departments. In material science lab, we have that. Okay, so we can go and see the structure of that material, nanoscale level. We can see the structure of that. Okay, that is used. Then these are applications. Also note that X-rays are dangerous. X-rays are dangerous. X-rays are dangerous for human health if exposed continuously. Continuously. So continuous exposure of X-rays is not good. Continuous exposure of X-rays is harmful for human body. Okay. And so this is X-rays. Next, let us go to ultraviolet rays. Let us move to ultraviolet rays. Okay. So next thing is ultraviolet UV rays. Ultraviolet rays. Okay, let us note ultraviolet rays. What is the wavelength of this? Note the wavelength in lambda. Lambda is going to be nearly 0.6 nanometer to 400 nanometer. 400 nanometer. This is wavelength range. Okay. And how it is produced? So UV rays is produced by very hot bodies, very hot bodies, and some special lamps, UV lamps. Okay, so this is how ultraviolet radiations are produced. Ultraviolet radiations are produced by some lamps or very hot bodies. Some bodies which are very hot, they will emit these ultraviolet radiations. Okay, like for example, you can say sun, right? Sunlight which is coming, it has ultraviolet rays. I think you know that. Ultraviolet rays, if you directly see to the sun, our eyes may get damaged. That's why sometimes we need to wear glasses to filter that UV rays, right? So even these spectacles that we wear, they have some ultraviolet, filters, so that ultraviolet rays should not enter our eyes. Okay. Then sun has all those things. You can write it. Okay. Also note that UV rays applications. Let us write applications. Applications. UV rays, ultraviolet rays, right, are used for LASIK eye surgery. I think for the surgery purpose they are using this. Okay, eye surgery. They are using this ultraviolet rays. Also note another application that UV lamps. That's the special lamps. Okay, UV lamps. So UV lamps are used to kill germs in water purifier. In water purifiers. So in water purifier, AquaGuard or other things you may have in your home. So you may see that there is a UV source is there, or UV lamp is there, which will emit some ultraviolet rays, which will kill the germs. Okay. So for, you can say also for wastewater treatment they can use it. Okay. For treatment of wastewater. Sometime in industries, the industrial waters which come, that is very polluted, so they may want to reuse those water. For that they can use this ultraviolet light to kill the germs, right? So they can use for wastewater treatment. Then let us go to the next. Visible light, I think there is no need to mention about visible light. You have the idea of visible light, the light which we can see. That without this visible light we cannot see anything. Visible light, so already I mentioned this is violet, indigo, blue, green, yellow, orange, red. But note the wavelength goes nearly 340 nanometer to 700 nanometer. This is the range of the wavelength. Okay. And yeah, that's the range of wavelength. If you want to draw a diagram, a rough diagram, you can note this. Violet goes from 400 nanometer to nearly 450 nanometer. Then indigo, I think they have not mentioned. Blue is there. Blue goes from 450 nanometer to 500 nanometer approximately. And green color will go from 500 nanometer to nearly 550 nanometers. Yellow color will go, yellow color, yellow color goes from 550 to 600. Then orange color, orange goes from 600 to 650, and then 650 to 700 is red. Okay, all these are nanometers. So this is orange and this is red. Okay, this is rough, rough range of different colors that we can just remember in case if you want. So here to here, this is violet color, and then 450 to 500. I think there is a 50 difference is there, that you can know. 400 to 450, 50 difference is violet. 450 to 500 blue, 500 to 550 green, 550 to 600 yellow, 600 to 650 orange, 650 to, I think, 50-50 gap is there. Indigo is not given here. Okay, maybe indigo will lie somewhere in between, near to 450 it will lie. Okay, its range may be very small. Okay, so that they have not shown here. Okay. So this is the approximately range for this. Then next we will go infrared. Let's go for infrared waves. Infrared waves, it has a wavelength range starting from 700 nanometer to 1 millimeter. Okay, so this is the wavelength of this. This is also known as heat waves. Heat waves. Another name for infrared is heat waves. So if you see heat radiations, right, and during summertime you are facing lot of heat radiation, heat waves. That heat wave is nothing but infrared waves. Okay. Yeah, 700 nanometer. See, if it is becoming 1000 nanometer, it's a big range. It is, yes, you have observed correctly. This range is quite large. 1 millimeter means 10 to the power minus 3, right? So 1 millimeter almost it is how 1 million nanometer it will be. because 10 to the power 6 nanometer. Yes, right. So 700 nanometer to 1 millimeter is quite a large means range is that wavelength range. Yes. They are readily absorbed by H2O, CO2, and H3. Water molecules are present in many of the daily life materials get heated by absorbing any infrared polymer. Our Earth receives energy from sunlight. It reduces premature infrared radiation. This radiation energy is unable to escape the atmosphere and reduce the H2O molecules. So here note that there are some greenhouse gases. You might have heard this term greenhouse gases. Greenhouse gases. These greenhouse gases are like H2O, CO2, NH3, methane. Okay, all these molecules. Why? Because these molecules, okay, in the atmosphere absorb significant part of radiation. So these molecules absorb infrared rays. Okay, these molecules absorb infrared infrared rays emitted by Earth. So Earth, what happens? Earth is receiving sunlight and Earth gets heated up. So Earth will emit infrared radiation. So as Earth emits infrared radiation, these molecules present in the atmosphere will absorb that infrared radiations. That's why the atmosphere become hot. Okay. So they are used to, these gases will trap the heat energy. Okay. And because of this global warming also happen. Global warming global warming happens because of these molecules trapping trapping heat waves in the atmosphere. These type of points are very important to write in your board exam. You can write these factual informations. Okay, what are some of the applications? Let us write applications. Applications are infrared 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 detectors infrared detectors are used by satellites. Okay, are used by satellites to gather photographs 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 for military purpose military purpose okay, and also for cotton farming cotton farming not only cotton but other type of farmings also. Okay, because some crops require high temperature or some crops require low temperature. So by using this satellite we can gather informations about the infrared radiations on the earth. Some region is hot because infrared are getting more trapped there. Some regions are relatively cold because infrared radiations are lesser in the environment there. So we can plan what kind of farming we want to do. That is one application. Another is military purpose. So if suppose military is more, some country is going to attack others. So using this we can see the movement of military, because in the this infrared sensors can show that. Why it will show? Because every object, including human beings, will emit infrared radiations from their body. So we are emitting infrared radiation, so we can capture that. Also, during the corona time, they used infrared sensors or detectors to figure out if your body temperature is high near the airports and railway stations and other places. They use these infrared detectors to detect whether you have got fever or not. If you got fever, then they will put you right. They will not allow you to move. No, you cannot move here and there. They'll put in detention. Somewhere they will put it. No. That time lot of problems were going on. So like that it happens. Okay. So these are the important applications. And also one more application, one very common application is there. What is that? All of us know that in our home. Where do we use infrared? Yes. Anyone know that? Infrared. Huh? In washing? What? That? Muscle strength also. Yeah, that also can be possible because where thermo thermo cells. What is that? Could you explain a little bit? Okay. No, that is of course it may be there. I am not sure, but one very common thing. Can you tell? Very common thing. Huh? Infrared in homes. You told turbo cells, huh? Tirmiska, I did not get turbo cells. You told TH, thermo TH thermophils. Thermophils. Yeah, I think there also they use. Thermophils are used for what? Heating purpose or maintaining temperature of that some liquid or something, right? Is it that? Something like that. Right. Very common. Come on, you do watch, na? You watch na movies or you watch television. Television remote. How that remote is working? Okay. So remotes. Okay. So write down this. TV remotes, TV remotes, and you find out many other applications will be there. Okay, some of that you mentioned, right? To treat muscles, to treat muscles. You find out many more applications will be there. TV remotes use that. Okay, TV remotes use infrared infrared rays. Okay, to send to send signals to send signals to television. You can switch on, switch off, change the channels. All those things are working due to that only. One more application I will tell, which I have seen in the industries, that is called pyrometer. Okay, pyrometer. Now, what is a pyrometer? One important thing that this suppose if you I have to measure the temperature of a body of human body. Suppose you got fever, so I can measure by putting a thermometer. You have to put in touch with the body or put in mouth for some time, and then the temperature will become stable and you can measure that, right? All of you have seen that mercury thermometer or clinical thermometers they have used. But nowadays, a pyrometer device has come, which is infrared sensors. which can detect the temperature of the body without touching. It is like a non-contact thermometer. Okay, just by putting that near you, it can measure your body temperature. Okay, so that pyrometer is nothing but it's an infrared sensor. Infrared sensors, okay, are used in industries to measure temperature of the body without contacting, without contacting. Pyrometers are used. Okay, so lot of applications are there. This next, uh, yes. So infrared radiation. What is the range of wavelength? It was very high. That is very high, right? So it has got lot of applications are there. So in nature, you can see this is a very large range of wavelength which is used for different purpose. Even animals use that. Snakes can feel the, of course, snakes can see the vibration. That is one thing. Another thing, it can also sense the heat waves, right? Heat waves it can sense. So lot of applications are there. Some major applications we are writing, but there will be many applications you can explore that. Okay, then let us go to the next. Next is microwaves. Microwaves wavelength range. Wavelength range, let us write, is 1 millimeter to 1 meter. Okay, and this electromagnetic have high frequencies in this range. Okay, high power microwave sources are okay. How it is produced? Microwaves are produced using high power microwave sources using special vacuum vacuum tubes vacuum tubes, known as known as magnetron. I don't know how to spell this word. Magnetron. We have to mark up this. Maybe for NEET it is important. This time they have asked this. Okay. This time before re-NEET on 3rd May that NEET exam which happened, there was exact table question coming from NCERT on this. Okay. And if you remember that table, they can search. Gun diets, yes. That also is there. Note that. Low power sources or use devices like gun diodes and impact diodes. Okay, that is one. It is produced. This also note that low power sources use devices like gun diodes and impact device diodes. Okay, gun diodes and impact. I don't know the full form of it, but we'll check about it. Impact diodes. These also produces this microwaves. Okay, these also produces microwaves. Remember that. Hmm. Okay. That her name is just sister's name is that Samyukta, right? I forgot to tell. Uh, yes, and her name is Tarunika. right? So today onwards they join, right? Okay, so gun diodes. That's why I got initially confused with that. Okay, so no need to worry. So no need to worry. Okay. So next, yes, what I was saying. Microwaves have shorter wavelength than radio. This causes less reflection. This makes suitable for radio. So, okay, note that these microwaves are used for communication, used for communication, used for communication over short distances, over short distances, over short distances. Okay. Using radar. In radars, they are using radar is generally for radio waves navigation purpose, but they also use this. Okay, they require a small antenna compared to radio waves. Microwaves are also important. And another most important thing is what all of us know that microwave oven. Ah, yes, that's cooking microwave oven. Uh, microwaves, microwaves are used for cooking food in microwave oven. Microwave oven. Now here sometimes questions are there. Here it is not mentioned in this book, but I have read somewhere in NCERT that how it heats the food. Actually, there is some concept there. They may ask also in your board exam or NEET or JEE. They say that this microwaves, the frequency of microwave matches with the frequency of the molecules, water molecules, right? And there is a resonance happens, and because of that resonance, lot of energy is produced, right? Something like that. Have you studied in NCERT? Yeah, something like that is there, but I will tell better read the NCERT. There they have explained this, I think. So how it works? How it works is based on this only. So the frequency of this, how it works. So frequency of molecules, molecular vibration, molecular vibration matches with matches with matches with microwave frequency, which leads to resonance condition, which leads to resonance condition. Okay, this helps in heating of food. Okay, so that is one of the reasons how it works. Then next and the last one is radio wave. Radio wave is the lowest energy. So I think this we have taken microwave. So microwave is which number? I think before that we are writing numbers. No? Which number is it? Infrared was which number? It was fifth. Sixth number it is. It was sixth number microwave, and then last we are going for radio waves. Okay, last is radio waves. With this we'll wind up this chapter. Okay. Radio waves. How radio waves are produced? And first also write down this wavelength range. So wavelength range is going from uh, fraction of meter to over few kilometers. fraction of a meter, fraction of a meter up to few kilometers. Okay, wavelength range is up to few kilometers. And how it is produced? Radio waves are produced. Radio waves are produced by oscillating charges. By oscillating charges in an electric circuit. Which electric circuit? Can you guess? Previous class. Can you guess which electric circuit we produce? Which electric circuit we produce? LC oscillation circuit. Remember, LC oscillation circuit. Huh? Fraction of meter means maybe 0.1 or 0.2 meter to few kilometer. Few kilometer means we don't know exactly, but it is written. But in NCERT, you see, NCERT exact values they will give. Okay, maybe 10 kilometer, 20 kilometer, few kilometer, how much it is that we'll see in NCERT. Okay. No. You see what it means is this is the wavelength of the radiation. Wavelength of the radiation is this much. Laboratory means small only. So wavelength means few kilometer means it can travel. This wave can travel up to that many kilometers. Okay. It is produced, but it can travel from one place to another place. It's not that the device or the laboratory, that device should be that much kilometer size. No. This is the size of the wavelength. So wavelength can travel over kilometers from one place to another place. Then what it is? But see, these wavelengths cannot travel more than few kilometers. But suppose if you want to travel, if you want to send radio waves from one place to very large distances, then there are some different techniques called AM, FM radio waves. You know that frequency modulated, amplitude modulated. We can modulate it and modify the signals and send over large distances. Okay? Those things we can do. That was in communication chapter, but it is removed from the syllabus. So I think that's all. So these radio waves also have different ranges. Okay, let us note radio wave frequency ranges. Frequency ranges. So if you take radio wave frequency ranges, there are different wave amplitude modulated AM. AM means amplitude modulated radio waves. Amplitude modulated radio waves, they have a range of 530 kilohertz to 1710 kilohertz. This is the range of frequencies. Okay, and they were used previously. Then what else are there? Higher frequency ranges are also there, like we have 54 kilometer are used, higher frequency up to 54 megahertz. Okay, up to 54 megahertz. Okay, signals are also used. Uh, these are called short wave bands. Okay, and these are used in uh, all India radio. All India radio they use. Okay, used by All India radio. All India radio. All India radio they uses this. Okay. Then there are still higher frequencies which are called FM waves. Okay. So 54 megahertz to 890 megahertz. Okay, this frequency range is very high frequency range. This is like it's called FM. FM is, I think, uh, FM is different. FM is, I think, it 88 hertz, 88 megahertz to 58 megahertz to 108 megahertz. This is called FM. FM means frequency modulated. Frequency modulated radio waves. All these are just information. In case you have to write notes on this, you can write it. TV waves. This range is for TV, television range. Range of television that we are seeing. Television has very high frequency ranges. Okay, and mobile phones also are working on some ranges. Mobile phone works on more than that. 1710 to 1860 megahertz. That is mobile network, mobile phones, mobile phone range. So the mobile phone works on this frequency ranges. Done. I think we are done with this chapter. Anyone any doubt? Do you have to remember this? Nothing can be done in this. Okay. Now NCERT. NCERT table. I think I will highlight that table in NCERT. It's a very important thing that better you refer to that table. In NCERT, that table is given. I have this old NCERT. If you do not have old NCERT, please download it from our app. Okay, so it is there. All the materials, including NCERT exemplar book, is also there. Okay, so you need to install that app and download it. Also, for writing the tests, also you have to use this app. So this NCERT book is there. Chapter 8 will be there. In chapter 8 you will find this. Okay, so I will draw there at least some this NCERT is important because you need to follow the values for that. So see the radio waves, they have given the wavelength greater than 0.1 meters. Okay, for microwave they have given the wavelength between 1 millimeter to 0.1 meters. Then infrared they have used wavelength as 700 nanometer to 1 millimeter. Then visible light, that is 400 nanometer to 700 nanometers. Then UV rays, ultraviolet rays, that wavelength is from 1 nanometer to 400 nanometers. And X-rays wavelength range from 10 to the power minus 3 nanometer to 1 nanometer. And gamma rays wavelength is still smaller than 10 to the power minus 3 nanometer. So if they ask in your board exam or even in NEET or JEE main, you have to use this information. This will never contradict. Okay. So this data or this value NCERT, this is always correct. You can use that. Fine. Done. So can we solve few questions? Or do you have any doubts? Yes? Anyone having any doubts, please ask. Any doubts in this chapter or any other chapter also? Anyone, any doubt? Kshatrish, Onish, Vishant, Veronica, Sam, Vishant. Anyone else? Doubts? Lalit. So let's just solve few questions then. Okay. We'll solve some questions, NCERT questions. Let us solve few NCERT problems. So NCERT, let us take question 10. We'll start from last class. I think we have solved question 1, question 2 we have solved. Okay, let's start in the same order. Question number 3, let us solve. What physical quantity is the same for X-rays of wavelength? X-rays, we are saying X-rays wavelength is given as 10 to the power minus 10 meters. Okay, what physical quantity is the same for X-rays of wavelength is, and red light wavelength, also they have given 6800 angstrom, and radio waves they have given here, radio waves wavelength 500 meters. So they are saying what physical quantity is same like X-ray, same like radio wave, same like red light colors. What do you think about it? Which physical quantity is same? Anything, whatever comes in your mind, you can think about it. Physical quantity means anything whose value is same as, this is like 1 angstrom, right? This is 1 angstrom. So anything which is same as one, any size of some object which you can think about it. 500 meter means what? Some like size of a room, maybe 500-meter length or something like that. You have to think some. This question is quite like ambiguous. Means what is which physical quantities here? So 1 angstrom. What is that? Is it atomic size? Might be. Atoms have some sizes in the range of angstrom. The atomic size. Atom. Atomic size. Sizes of atoms comes in the range of that. If you take hydrogen atom size is nearly 0.5 angstrom. Radius of first orbit. Like that, similar way, figure out this. Okay, where it is. This I already I told some size or of a room. Size means length or width. That's a physical quantity. Okay, which is similar to that. That also you think about it. There may be many answers, but you can think about it. 6800 uh, angstrom. Maybe it's a molecular size. It will come in nanometer, I think, right? The 680 nanometer. It may be molecular size. Molecular size, right? Some molecules may have size of the range, but you think about those. I don't know the exact key, but you check. Is there any other answers given for this? But this answer is coming in my mind, so we'll think about that. Any other answer can also be possible. Okay, let's go next. Question number 4. A plane electromagnetic wave travel in vacuum along z direction. What can you say about the directions of electric field and magnetic field vectors? So, suppose if I consider this as x-axis, this is y-axis, this is z-axis. So they are saying that electromagnetic wave is going in this direction. So this is the direction of propagation of wave. Direction of wave propagation. Propagation. So wave is going along z direction. Now they are asking which direction can be the direction of electric field, magnetic field, and they have also given the frequencies 30 megahertz. 30 megahertz. What is the wavelength? We have to also calculate the wavelength. Okay, let us consider this question. So first of all, you know that the direction of velocity vector is parallel to E cross B. Yes, remember that V E cross B gives the direction of velocity. So suppose this is velocity. So E cross B you can take electric field along x-axis and magnetic field along y-axis. Okay, E cross B is giving z direction, right? So E cross B should give the velocity. So this is the direction of velocity. Okay, this is the direction of velocity of wave. So E cross B is parallel to V. Okay. So this is one possibility we have taken. Otherwise, you can take any other direction of means in this plane. So note that electric field and magnetic field uh, are in xy plane. XY plane means anywhere along x and y. It may be. It's not necessarily that it has to be only along x and y, but they have to be perpendicular. So one other direction you can also think any other direction you think. Suppose if I take electric field like this and magnetic field like this, okay, they are perpendicular 90 degrees. So E cross B is still coming out. So first E must be there, then B must be there. E cross B thumb is coming out. So you can do it like this, okay, because this z axis is giving us the velocity vector. E cross B can be anywhere in the plane of x and y, but they must be perpendicular. That's the main thing. Okay, so in objective questions, they can ask is C vector and V vector need only has to be along x and y, not needed. Electric field and magnetic field can be present in the plane of x and y and they must be perpendicular. They can be in any direction. Clear? This thing should be clear. Okay, now calculation. They are asking wavelength. So we all know that speed is equal to lambda into frequency. Speed means speed of light, or any electromagnetic wave is going with the same speed. That speed is 3 into 10 to the power 8 meter per second. So use this formula, lambda into this is 30 megahertz. Mega means 10 to the power 6. Calculate this lambda. Calculate this. 3 will get cancelled. And 7, 10 meters. 10 meter is the wavelength. Can you tell me which kind of wave it is? Yes, this is extra question now. Which electromagnetic wave it is? Tell me. Meters it is. Is it radio waves? Check that. Radio waves only? Radio waves. This type of question they can ask. Okay. Because radio waves is greater than wavelength greater than 0.1 meter. Right? So we can remember these things. Okay. Huh? Yes? Anyone else? Any doubt? Ask. Correct, na? Is this correct or not? Radio wave is greater than 0.1 meter. So 10 meter is greater than 0.1 meter, right? Okay, next question. Can we move to the next question? Question number 5. Let us go to next question number 5. A radio can tune into any station in the 7.5 megahertz to. So radio station is tuning in between that 7.5 megahertz to 12 megahertz. This is called band. Band means this is the bandwidth in between this. Okay. So the question is, what is the wavelength band? Wavelength band. This is called frequency band. Frequency band. Frequency band means this is the range of frequencies. We need to find out wavelength band. Wavelength band you calculate. How to calculate wavelength band? So note here that this is the minimum frequency and this is the maximum frequency. So we know C is equal to lambda into frequency. This formula we will use. So lambda will be C by C is nothing but velocity of light, right? So if you use minimum here, then you will get maximum wavelength. So now let us calculate maximum wavelength. Maximum wavelength, ah, yes. Frequency band is range of frequency of electromagnetic wave. For example, let us take radio signals. Okay, radio signal. Let's suppose some radio station is there. They may send some radio signal within a particular range. For example, they are playing. Let us say some music program is there somewhere, and that program they will broadcast using some frequencies within a particular range. And if you have radios, you can tune within that range of frequency, and then you will be able to catch that frequency. Suppose somewhere some cricket is going, and that cricket commentary they are sending at a different frequency range, so their band will be different. Otherwise everything will mix up, right? So different means frequency ranges are used to send different signals. Okay, so if you take this is like a radio, right? We have discussed, I think, different amplitude modulated, frequency modulated, high band, short band. Remember, we have discussed that. You can see here, I think. Here I think we have covered that. Yes, here you see AM wave. So these radio waves are sent using this different range of frequency. These are called band. Band means it's a range. So we need to calculate in that portion. We need to calculate the wavelength band. Wavelength band means range. Range. Let us calculate range. Wavelength range. So this formula we are going to use. Now tell me. Let us substitute. So if you substitute minimum here, this will come maximum, because inverse relation is there. And speed of light, 3 into 10 to the power 8. Let us do this calculation. Substitute minimum 7.5 mega 10 to the power 6. Do this calculation fast. What will be answer? Tell me. So I think some calculation can be done here. Do it fast. Remove this. 110 will come here. 325 times it will get cancelled. So 6 will get 1000. It will be right. 1000 by 25 it will be. Check out this, how much it will be. 40 it will be 40 meters, only meters. Okay, then similarly you calculate, if you use frequency maximum, you will get minimum wavelength. So what is minimum wavelength? Same way you calculate 3 into 10 to the power 8 divided by maximum 12 megahertz. 12 into 10 power 6. Calculate. 1 by 4 will come here, and this will come 100. So that means 25 meters. Yes. So the wavelength band, let us write wavelength band. Wavelength band means range of wavelength. Minimum wavelength 25 meter, 25 meter, maximum 40 meter. So 25 to 40 meter is the wavelength band. Clear? Yes. So like this you can calculate. Done. All of you got this? Yes. Okay, move next question. Question number 6. A charged particle oscillates about its mean equilibrium position with a frequency. So frequency of oscillation of charged particle is given 10 to the power 19 hertz. So some charged particle is there. It is oscillating about the mean position. This is the mean position, and this will be extreme position, extreme. This side also will be extreme, just like SHM. A particle is just doing simple harmonic motion. This is a charged particle. What is the frequency of electromagnetic wave? So question is, what is frequency of electromagnetic wave? What is frequency of electromagnetic wave? Anyone can give the answer? This is a charged particle. Yes. Tell me the answer for this. The particle or the source is vibrating at this frequency. So note that the vibration frequency of the source is same as frequency of the wave. You have to note this, because the frequency at which the charged particle is oscillating, just like in LC oscillation circuit also, if you remember, the formula omega was 1 by root LC. Do you remember that? This was the oscillation frequency, oscillation frequency, oscillation frequency of charges, of charge or current. Remember this? This is similar to resonance. Yesterday means last class we discussed that. So this frequency is omega is the same frequency of the waves which is produced. So similarly here also this frequency of this source is same as this you note. Source frequency is same as wave frequency. In short, remember source frequency is same as is equal to wave frequency. Wave frequency. You may ask question why it is like this. You can ask why it can be like this, why it should be like this. So for that, try to very easily understand with the example of a wave, how wave is produced. Suppose this is a rope, and suppose this rope I move up, I move down, I move down, I will move up like this. Suppose if I give one time, one time I move, this is one complete cycle of moving up and down, one complete oscillation. If I give one complete oscillation, I will be producing one wave, and if I do next oscillation, I will produce next wave. Are you understanding this? This is a very important thing. In waves chapter in grade 11 you must have studied that. If you give one oscillation, one complete cycle of to and fro motion, it will produce one disturbance. If you next cycle, if you do, it will produce next wave, like that. Okay, so that means number of oscillation per second is same as number of waves per second. Yes, are you understanding this? So number of oscillation per second is same as number of waves produced per second. That is why source frequency and wave frequency are same. Okay, done. Then what? Next, let's take last question. This is last question for today's session. Question number 7 with wind up. Amplitude of magnetic field in a harmonic electromagnetic wave. Magnetic field amplitude they have given 510 nano Tesla. What is the amplitude of electric field? Calculate E naught. Yes, tell me E naught. Quickly, fast. Give me the answer. All of you give the answer. How is electric field amplitude, magnetic field amplitude related? How are they related? Remember formula. What is that? Yes, Lalit, Chatresh, Monish, Vishant, give the answers. Veronica, anyone? Fast, you have to be fast in calculation, right? You have to do fast calculation. Yes, come on. No? What is the formula? What is the formula? Can anybody tell the formula? Have to revise class notes. Oh, otherwise it will be waste. You need to definitely make proper notes. Huh? How much, Salif? Yes, yes, correct. E naught by B naught is equal to C. Over, game is over. Now you can calculate. So E naught is equal to C into B naught. Substitute C is the speed of light, 3 into 10 to the power 8. And this B naught they have given 510 nano. Nano means 10 to the power minus 9. You can calculate this first. So E naught is equal to, this you multiply 313, 3 into 5, 153, and this is 8, 9, gone, that is gone. This much only, right? Electric field unit, Unit of electric field. Tell me, volt per meter? Yes. Done. One step. What are you thinking about it? Clear? Yes. All of you have understood this? Done. So let us wind up this class today. Okay. Then we will see tomorrow. Tomorrow grade 11 class will be there. Okay. Then we'll see tomorrow. All of you can join grade 11 topics also. We have just started grade 11 topics from basic maths. So if you are interested, you can join it parallelly. You will be covering 11 as well as 12. Okay. So let us meet in the next class all. Bye bye all. We'll see you next class.